No questions on chapter 8? Okay. We are now going to do some example today on comparing two means, two proportions, that is 8.5. Remember, in hypothesis testing, we need to identify the claim, state the hypothesis. The null hypothesis is when there is equality involved. The alternative hypothesis is the opposite of the null hypothesis and vice versa. The population is normally distributed or the sample size is large enough. We can either use the Z or the T distribution to test the null hypothesis. We use the Z distribution when sigma is known and the T distribution when sigma is unknown. So in case of paired data, we take the difference and test the difference as a single distribution. We use the Z test for proportion when NP is greater than or equal to 5, NQ is greater than or equal to 5. The number of success is at least 5. Number of failure is also at least 5. Then we use the Z. You will always have those conditions, but it's good for you to know that without those conditions, we wouldn't have been able to use those distributions. So we discussed before about dependent and independent variable, dependent and independent samples. So when values are taken from the same individuals in pairs, we have dependent samples. Otherwise, we have independent samples. For independent samples, we can compare the difference of the mean using the Z distribution when the sigma for both populations are known. Otherwise, we will use the Z distribution. On your calculator, you will have two samples Z test and two samples T test. So if sigma is known, we use the Z test when both sigma are known with the formula that we have here, which is just essentially taking the difference of the sample means and divide by the standard deviation of the distribution of difference of sample mean, which is here sigma 1 square over n1 plus sigma 2 square over n2. So we follow the same method. The consumer group is testing CAM stoves to test the heating capacity of a stove. It measures the time required to bring 2 quarts of water from 50 degrees to boiling at sea level. 2 competing models are under consideration. 10 stoves of the first models and 12 stoves of the second model are tested. The following results are obtained. So using the calculator, if you want to solve manually, you will need to know what are sigma 1 and sigma 2. We first have the sample mean, x1 bar equals to 11.4. Sigma 1 equals to 2.5. And n1 equals to 10. This information are from the example. X2 bar equals to 9.9. Sigma 2 equals to 3. And n2 equals to 12. So from your calculator, you will go to start test and choose 2 samples Z. Z, because sigma are given, we use Z. Remember, we use Z when sigma are given. Z, 2 sample Z test. Has anybody seen it? What number is it? 3. Number 3, when you go to test. So the information is on the board here. So the Z test is x1 bar minus x2 bar over square root of sigma 1 square over n1 plus sigma 2 square over n2, which is 11.4 minus 9.9 divided by square root of 2.5 over 10 square plus 3, 2.5 square, 3 square over 12. So using calculator, what is the test value? Or do you have a question? We want to test if there is a difference between, is there any difference? Okay, I didn't say that. Is there any difference between the two stuff? So our claim is there is a difference. So H1 is different. So we can have H0, mu1 equal to mu2. H1, mu1 is different from mu2. Or mu1 minus mu2 is equal to 0. Mu1 minus mu2 is different from 0. Alpha equals to 0.05. So anybody has a test value? $1.279, we will just write 1.28. So just to refresh our memory, the test value is 1.28. So the p-value is this area. Here is half of the p-value because it's a good value. So the p-value is 2 times this area. So you will see that, what is the p-value? What is the p-value? Yes.
I didn't get that.
For the test value?
Yeah.
What do you get?
1.4.
1.4. Let me check what you get. How did you do it? Did you... Oh. Anybody else got 1.44? What do anyone else have?
1.279. So that's a 4.
So change that to 11.2. So what is the p-value? 0.2. It's because I know that this is the critical value for a for a confidence level of 20. So that is why I could know that the tail is out of 20. So is this what should be our decision? Is P greater than or less than alpha? Is the P value greater than or less than alpha? It's greater than alpha. So do not reject it zero. Conclusion, at alpha equals to 0.05, there is not enough evidence to support the claim that there is a difference between the two stoves. Or we could just answer the question that we have at the 5% level of significance, the sample data do not indicate any difference in the population. There is no difference between the two stoves. If the company was to decide to change stove, we will advise the company not to make the change because the sample we have at hand does not indicate a difference between the two stoves. So when sigma is unknown, we use the T distribution. So we are going to do an example with the T distribution. Two competing headache remedies claim to give fast-acting relief. An experiment was performed to compare the mean length of time required for bodily absorption of brand A and brand B headache remedies. 12 people were randomly selected and given an oral dosage of brand A, and 12 were randomly selected and given an equal dosage of brand B. The length of time in minutes for the drugs to reach the specified level in the blood are recorded. The mean standard deviation and sizes of the two samples are as follows. I want us to record this one before we proceed. We are recording letter to the type of test we want to do. Here again, x1 equals to 21.6. Now it is S1 which is given, not sigma. S1 equals to 8.7, N1 equals to 4. X2 equals to 18.9. S2 equals to 7.5. N2 equals to 12. So past experience with the drug composition of the two remedies permit researchers to assume that both distributions are approximately normal. Let us use a 5% level of significance to test the claim that there is no difference between the two brands in the mean time required for bodily absorption. Also find an estimate of the p-value of the sample test statistics. So alpha again here, 0.05. What is the claim? What is the claim here? What is the claim? There's no difference. That is mu1 equal to mu2. So H0 will be mu1 minus mu2 is equal to 0. H1 will be mu1 minus mu2 is different from 0. The test value will be T equals to x1 bar minus x2 bar over square root of s1 square over n1 plus s2 square over n2. So we'll have T equals to 21.8 minus 18.9 divided by square root of 8.7 squared over 12 plus 7.5 squared over 12. So using your calculator with number 4, two sample t-test, what is 0.87, 0.875. Anybody has something different? I can always come to check to help you. That's why I keep asking that question. Okay. So now, to find a p-value, we can either look for an approximate value of p using the t-distribution table, or just read it from your calculator. So if you are doing that, you will find that this test value is between 0.697 and 1.214. From the table, those are the two numbers that are closest to it. So we move up because it's a two-tailed test and we are between 0.5 and 0.25. So what is the p-value that you have? 0.39. With this p-value of 0.39, it is between 0.25 and 0.5. That is what the book will give you as the range of values whenever you are asked to find a range of values for the p-value. But when you have the p-value, you don't need to use that method. Is this p-value, let me explain again. 0.25 less than p less than 0.5. How do you use this range? If you know that p is greater than 0.25, then it is greater than 0.0. That's how you use the range. But now we have the actual value, and what should be our decision? P is what, greater than or less than alpha? Greater than alpha. So do not reject it. Our conclusion will be there is not enough evidence to reject the claim, or we will say that at the 5% level of significance, there is insufficient evidence to conclude that there is a difference in mean time between the two drugs. Again, if the company wanted to move from the old one to the new one, they will not need to do that, especially if the new one is more expensive. If the new one is cheaper, then they will say, well, we don't lose anything going for the new one. That's how we make decisions in statistics based on the sample. Now comparing two proportions. To compare two proportions, we will use the Z distribution provided that the number of success for both samples are at least 5, and the number of failure is also at least 5. The sample proportion is P1 hat equals to X1 over N1, and P2 hat equals to X2 over N2. So the test, I'm sorry, the statistic will be P1 hat minus P2. Which is equal to X1 over N1 plus X2 over N2. We are going to use calculator. I'm just explaining. For proportion, we are going to do something that we have not done in confidence interval for hypothesis testing. We are going to find a pool proportion. To get a better estimate of, normally we were supposed to say Z is equal to the test value is ZC times, sorry. The test value is P1 hat minus P2 hat divided by the square root of P1 Q1 over N1 plus P2 Q2 over N2. You don't really need to write this. But we don't have these P1 and Q1, which are population proportion for the first population and for the second population. We can use the sample proportion as we did for confidence interval to estimate. But a better estimate is achieved by using the pool proportion. Which will be, the pool proportion is P bar equals to putting both samples together. I'm using X here, so I can use X here. And the test value will become P1 hat minus P2 hat divided by the square root of P bar Q bar times 1 over N1 plus 1 over N2. So if you are not using calculator, you have to remember to make this adjustment. So let's look at this example. The Macha County clerk wishes to improve voter registration. One method under consideration is to send reminders in the mail to all citizens in the county who are eligible to register. As part of a pilot study to determine if this method will actually improve voter registration, a random sample of 1,250 potential voters was taken. Then this sample was randomly divided into two groups. In the first group, there were 625 people. No reminders to register were sent to them. The number of potential voters from this group who registered was 295. On the second group, so the information we are getting from here is that N1 equals to 625 and X1 is equal to 295. And the second group, again, 625 and X2 equals to 350. The county clerk claims that the proportion of people who register was significantly greater in group 2. On the basis of this claim, the clerk recommended that the project be funded for the entire population of Macha County. Use a 5% level of significance to test the claim that the proportion of potential voters who registered was greater in group 2, the group that received reminders. So what is the claim? The proportion in group 2 is greater in group 1. So H0 will be P1 is equal to P2 or P1 minus P2 is equal to 0. And H1, P1 is equal to P2 or P1 minus P2 is less than 0. So the full proportion will be P bar equals to 295 plus 350 divided by 1,000. This is the full proportion equals to 0.516. And the Q bar, which is 1 minus P bar, is 0.484. As I always say, you don't really need to be writing all that, but so using your calculator, can you use your calculator to do the work? to find the test statistics. For those who might be doing it manually, 295 over 625. And this is 350 over 6. So what do you get as the test value? Anybody has a test value? Anybody has trouble using calculator? Z, 2 proportion Z test. 2 proportion Z test. Anybody has a scheme for the calculator? It might not be written there exactly as I am saying. Anybody has it? So what do you see on your calculator? Is anyone using the calculator now? I just want to know if it is any question. Yes. Yes, but I want to make sure that is good. That means you are moving right. Anybody has trouble with the calculator? Okay. So for the hypothesis testing, we use the full proportion. I'm specifying this for those who might be working it manually, that you need to adjust to the full proportion. But if you're using your calculator, there is no problem. So we have negative 3.11. Which we can find the p-value. What is the p-value? The p-value 9.26 times 10 raised to power, what is it? -4. The p-value is never a number greater than 1. It's a probability. So when you see it bigger than 1, look at that negative. So it is actually really small. So we can say p is equal to 0.000926. This is what the p-value is supposed to be. So is it for our decision? Is it greater than or less than alpha? Let's take alpha equal to 0.05. Is this p-value greater than or less than alpha? P-value is less than or equal to alpha. So reject. It's 0. There is enough evidence to support the claim that the county clerk was right, that reminding voters improve voters' registration. Okay. So this completes chapter 8. The remaining part of it is when you are using the critical value, which I will not come back to that because we are all using calculator. And if you were using critical value, that would mean that we are saying the critical value, for example, at alpha equal to 0.05. For a two-tailed test is 1.96. For a one-tailed test is 1.645. You know how to get those values. And you will compare the z value to the critical value. So this complete hypothesis testing for chapter 8. Now we will get to chapter 9. 2 more chapters to go. So you should be thinking about your project as we start chapter 9. Chapter 9 has 4 sections. Section 1, 2, and 3 will be part of your homework and the final exam. Section 9.4 is for the project. So section 9.4 is not going to be an exam. You don't have homework there to do. I think you might have homework as optional. You can do it to practice because you want to know how to do the project. So we will come back to it when we will still discuss it again on Thursday and on Tuesday next week. Correlation and regression. So 9.1, we are going to learn about scatter diagrams and linear correlation. In this chapter, my suggestion is the use of Excel. You can still use your calculator, but you know, I have been using more of calculator than Excel. And everybody has Excel. So we can use Excel for chapter 9, because this is the type of work that you can want to print your results to show someone what you did. With calculator, you cannot print. I mean, you can print, but it's not that most calculator cannot print. So correlation studies the relationship between one or between two variables or more. Between the variables that we call the dependent variable, another one that we will call the independent variable. Sometimes there is only one independent variable, and in that case, we speak of a simple correlation. In other cases, like we will see in section 9.4, there are more than one dependent variable. So y is the dependent variable. And x is the independent variable. This dependent variable is also called response variable. And this one is also called explanatory variable. Some people call this one also input variable and that one output, but it's not too common. For example, we may want to determine if there is a linear and but in a simple correlation, there are one dependent variable and one independent variable. In a multiple correlation, there is one dependent variable and more than one or multiple independent variables. You can write multiple independent variable or more than one independent variable. It's the same thing. For example, if you want to predict your score in a test, you can use You may also want the time because you might not respond well to the test. Then you will have to wait. If it is possible, you can also measure your level of anxiety. What I'm saying, there is still one. So when we have a simple correlation, we have two variables, x and y. We can represent it on a rectangular coordinate system. Here is x and here is y. To make what we will call a scatter diagram. This scatter diagram is useful in the sense that it can help identify the nature of relation between the two variables. We may be able to detect if there is actually a relationship or not. And if there is one, whether that relation is linear or non-linear. We are going to do an example later, but this is an example of scatter diagram. Let me show you another one. These are examples of scatter diagram. In this scatter diagram here, there is a relation, but it is not linear. In this one, there is no relation. So when there is a linear relation, we are interested whether that relation is positive or negative. Positive will mean as you increase x, y will also increase. As you decrease x, y will also decrease. That is a positive relation, and it is described by this diagram. The first one is a positive relation. The next one, the diagram B, is for a negative correlation. For example, the time you spend playing with your phone can be negatively correlated to your performance in the class. The more you spend time on the video, on the computer game, on your phone, the less you might perform in class. That is a negative correlation. The more time you spend studying, the higher will be your performance, is a positive correlation. So, a linear correlation could be perfect. In these two relations that we have up here, all the points are not on the line, meaning that that line is just a representation of the relation. It does not account for the whole relation. When all the points are on the line, we have a perfect correlation. So I will move to the next topic before we go back to Excel to discuss what we call correlation coefficient. The correlation coefficient helps us to determine the direction and the strength of the relationship between two variables. So it is a number between -1 and 1. The correlation coefficient is a number between it's divided by or population, the parameter, population, correlation with and R is the sample correlation. R is between -1 and 1. If R is equal to 0, there is no linear correlation between X and Y. If R is negative, there is a negative correlation. Between X and if R is positive, what do you think we can say? There is a positive correlation between X. This is about the direction. The second one is what determine the nature of correlation between two. The correlation coefficient is very the direction is positive or negative. And also the square. The closer it is to 1 or negative, the stronger is the one. The closer R is -1 or 1, the stronger is the correlation. And if R is equal to plus or minus, then there is the perfect. All these are all the powerful. I just summarize it on the board. There is a perfect correlation. So we don't really need to compute this formula, but I just want you to see what it is. That formula is what is used to compute the correlation coefficient. It's R equals to N sum of X times Y minus sum of the X times sum of the Y divided by the square root of N times sum of the X squared minus sum of the X squared N times sum of the Y squared minus sum of the Y squared. So this is the number. This number at the bottom is the absolute value bigger than the number of the top. So sometimes at your homework, you may be asked to use a calculator to confirm that these numbers are correct. Okay, how do I know? I don't really expect you to. I will not be there to see if you are using your calculator. So you can use Excel. If you are using your calculator, you put the variable in L1 and L2, and then use two variable calculation. So we can come back to that later, especially when we are doing homework. So I've explained all this. We are going to do an example now. In this example, we are going to use Excel to make a scatter diagram. It is as simple as what we did when we were making a pie chart. And then we are going to use Excel to compute the correlation coefficient. Sun driven by wind create large, beautiful dunes at the Great Sand Dunes National Monument in Colorado. Of course, the same natural forces also create large dunes in the Great Sahara and Arabia. Is there a linear correlation between wind velocity and the sun drift rate? Let x be a random variable representing wind velocity in 10 centimeters per second, and let y be a random variable representing the drift rate of sand in 100 grams per centimeter per second. So a test site at the Great Sand Dunes National Monument gave the following information about X and Y. So let's use Excel. I'm going to use Excel. So here is X and here is Y. So I'm going to enter the value of X on column A and Y on column B. You should do the same. We have 70. Well, the total value on column A, X on A, Y on B. Now, have you entered the data in Excel? Okay. So we will go to data analysis. You know how to do, click data first, then data analysis. Data. Then data analysis. Everybody has data analysis. Anybody that is missing the data analysis? Okay, good. So if we all have data analysis, we can proceed. We will choose regression. We choose regression here. So the y variable is this one. Let's highlight the y variable from B2 to B8. And the x variable is this one, from A2 to A8. I'm encouraging you to write x and y so that you know where to enter the values. If you start from 1, then you should click label here. You see the label here. If you had started from 1, it will include the labels, and you have to tell Excel that your labels are included. So I'm not clicking there because I did not put the label. So these places that are, this one will show us the line of This one will give us the line of best fit and the scatter diagram at the same time. If you click here. But you could get a scatter diagram without that. Everybody is at this point, you can just click OK. So we have this line. I might want to see the line. We are going to discuss it later. There's a line that is passing through the values. So this is because we want to have the scatter diagram, the line of best fit that we are going to learn later. And we also want to have the correlation coefficient, and a lot of information are here that we will be discussing as we move on. We are going to be discussing most of this information. So if you wanted just to have your scatter plot, suppose you just want your scatter plot, you just highlight the values like this, and then go to insert. And you choose this diagram, this point here. Then you have your scatter diagram without going further, just like we were doing the pie graph. So not very important for now. But if somebody asks you to make a scatter diagram, that is what you will be doing. So what is the correlation coefficient here? This is the correlation coefficient. You see multiple R, it is always written multiple R is for R, is the correlation coefficient. R is equal to what? What is R? R is 0.9. Okay, let's make it 9.5. We did this big work just to get that R for now, but it is going to give us a lot of information that we will need as we move on. I want you to get used to doing this work. So we have this diagram. Manually, this is what you are supposed to do. X, Y, find X square, find Y square, find X times Y. Put the sum below here, and then fit it into the formula of the correlation coefficient to get the 0.949. Okay. So, but you are using calculator, or you can use Excel. We are going to use calculator as well, so that you know how to use your calculator. But it's not difficult. You just go to put in X and in Y, L1 and L2, and then when we are doing the test, we will come back to calculator. Linear regression. So when you have a scatter diagram, I want to complete this because it's directly related to what we just learned, and I want you to put them together. Okay? So when we have a scatter diagram, we may want to know what is the closest line to all the points. We call it the least square line. The least square line, or the line of best fit. So this is our scatter diagram. We were looking for that point. So we should remember, what you want to remember here, that a line is defined as y equal to a plus bx, where a is the slope. A is the intercept. Intercept. and B is the slope. The slope is the amount of change of y per unit amount of change of x. Like you say 60 miles per hour. For each hour, you go 60 miles. That is the slope, the velocity in some cases. So a line of regression is expressed like this. So it passes through the mean of both x and y. That is, the sample mean of the y value is equal to a plus b times the sample mean of the x value. That is, the sample mean is a point of the line of regression. Should I write the formula to get the A and B? Actually, what's happened is that we call it the line of best square, the best of best, because suppose this is the line. This line is y equals to a plus bx. We want to know what is A and what is B. We will measure the distance from each point to the line. This will be D1, D2, D3, D4. You don't need to write this. So D is generally equal to, let's say Di is equal to xi minus x squared plus yi minus y squared. That is what is the distance between each point and the line. So when we get all the distance, x is any variable. So we are going to use calculus to find the minimum distance that will not help us to define A and B. That's just an example. Because we will use Excel. So B will be, when we solve that equation, we first have this relation, and we also have that B equals to n sum of xy minus sum of x times sum of y divided by n sum of x squared minus sum of x squared. I know these formulas are a lot of, you can remember those formulas like that. So all what is in this section is about explaining what that means. So you can see the formula for B here. And when you have B, you use this equation to find A. We get it from our calculator. So I want us to use calculator now. You still have your Excel, right? You still have, let's just look at Excel first for the data that we just worked on. Please, let's go back to Excel. What will be the regression line for this data? The regression line will be here. This is A is here, and this is B. You see intercept here, that's what it helps you to know that it is A. This is coefficient intercept. It is this one. And the coefficient for the X variable, it is here. If you have seen it, can you tell me what the regression line is for that data? What is A? Please, what is the intercept? And so, do you see what the intercept is? Negative 79.97. You did it on your Excel. Negative 79.97. And then B is 1.07 plus 1.07. Okay. So you have learned one more thing about Excel. I will just continue next Thursday. We are going to learn more about how to make the regression line.